My name is Patrick, and welcome to the webinar for today's session on OSI model. Today we have Mr. Devashish Roy, who is a CCNA Network Certified holder as well as a CompTIA Network Certified holder. He has been professional in the field of networking for the past 10 years and will be explaining to you about today's topic in a deep and interesting manner. If you have any questions regarding about today's topic, feel free to comment on our sections on LinkedIn, Facebook, and on YouTube, wherever it is possible. So, Mr. Devashish, please take over.
Thank you, Patrick. Hello, everybody. Welcome to CompTIA Network Plus webinar. My name is Devashish Roy. I'm the Senior Network Trainer as well as Cisco Network Specialist at the Indian Cyber Security Solutions. And these are my contact information for LinkedIn, Twitter, Facebook, in case you want to contact me. Hello, everybody. Let's start the CompTIA Network Plus webinar. I welcome you all. My name is Devashish Roy. I'm the Senior Network Trainer as well as Cisco Networking Specialist at the Indian Cyber Security Solutions. And these are my contact information for LinkedIn, Twitter, and Facebook in case you want to contact me. We'll discuss OSI model first. OSI means Open System Interconnection. And this is a model made by IEEE. It is developed by the proposals made by International Standards Organization or ISO. It is called ISO-OSI Model Open System Interconnection. And it is a reference model for all the computing systems, all the networking gadgets. So every communication from one PC to other PC, or one laptop to other laptop, one server to other server, any networking gadget, any communication you can describe with this OSI model. It is an open model, open standard model. There are different layers in this OSI model. There are 7 layers, and each layer is abstracted from the other layer's functions. Each layer is logical. The function of each layer should be chosen according to the standardized protocols. So there are some definite protocols working in each layer. Say, for example, you are sending an email, there is a protocol for that. You are just connecting to the website, there is a protocol for that. So for every function, there is a particular service defined. These are the 7 logical layers of the OSI model that we have. Starting from the bottom, that is physical, data link, network, transport, session, presentation, and application. These all layers are logical, means you can only describe the functioning of each layer. You cannot touch any layer. This is not physical. Okay. So we have to learn the functioning of each layer starting from the physical layer. So this is the approach of the OSI layer. Say 2 devices are communicating, and it depends on the service which layer is used. For any networking service, say you are sending a packet through router, the layer 3 is used. The data link layer 2 is used for LAN communication, or layer 1 is used in case of physical communication between cables. So this is the exchange of the data using the OSI model. From one PC, it is coming from top to bottom, and the other PC, it is coming from bottom to top. And 0 and 1 means the data is transmitted through binary format through the transmission medium or the cable. Now, first is the physical layer. So from the data link layer, the data is entering the physical layer, and the physical layer's job is to decrypt the data. See, if our data is coming from application layer to physical layer, the data is encrypted. And in the physical layer, the transmission medium or the cable is there. So in that cable, the data gets decrypted into what? In binary format, in 0 and 1. It is the bottom layer. It is responsible for actual physical connection, means cables, UTP, STP, coax, fiber optic, these cables are actually there in the physical layer, and it is concerned with transmitting the bits over a communication channel. So the communication is made through the cables in the physical layer. These are the functions of physical layer: transforming the bits into signals. It provides a synchronization, clock synchronization between the PCs. Transmission rate it defines. It provides the physical topologies that we have, the star, bus, ring, those topologies. Multiplexing, all these things happen in the physical layer. Next we have data link layer. So a data is entering from the network layer to the data link layer, or from the physical layer to the data link layer. It is the in-between layer between the network layer and the physical layer. So what are the functions of data link layer? It is responsible for the node-to-node delivery of data, and actually it is happening in case of LAN. In case of LAN, which is connected to a switch, their data link layer is very important, because in data link layer we see the layer 2 switching, or the switches or bridges operate in the data link layer. The physical address or the MAC address that the PC has, that MAC address is captured by the data link layer device switch. So we see there is a layer in the data link layer that is known as MAC, Media Access Control, that establishes a link between the devices in case of LAN, and it captures the MAC address. There is also another layer as LLC, Logical Link Control. This logical link layer is responsible for communicating with the layer 3 routing protocols. So we have the routing protocols in the network layer stack, and actually we have to done some communication. We have to connect to that routing protocols, and for that LLC is there. Now what are the functions of data link layer? First is the physical addressing. It maintains the physical address or the MAC address. It captures the MAC address of all the pieces connected to the port of the switch. Second is framing. This is also a very important thing. Framing means that in the data link layer, the entire data is divided into some different parts, means into different packets. You divide the entire data in different packets. Why? Because in case of Ethernet networks, we see that we have a particular frame size that is from 64 byte to 1500 byte. So any data, any frame below 64 byte or above 1500 byte will be discarded. So you have to actually maintain that size. The data link layer has to maintain that frame size. That is framing. Another one is flow control. Actually, if the two pieces are communicating, the data link layer ensures that the flow control is maintained so that too much data is not sent to the destination PC, because otherwise it will result in data loss. So this is an example of data link layer. From one PC, a data is sent to the other PC. You can see there is a destination address and source address. In between that is data, and also a trailer part, that where the data is coming from, the originator actually. Error control, definitely data link layer also has some other functions also. It checks the error in the data, and if the error is there in the data, if the data is corrupted, means error means the corruption, then data link layer checks that error and again tells the originator to send the data again. And there is a CRC check, cyclic redundancy check, that is done in the data link layer to detect the error. So that error control, access control, that is all done in the data link layer. Let's come to the network layer part. From transport layer, we see the data is entering the network layer as well as from data link layer. Network layer is responsible for source to destination delivery of packets, means routing. You are actually sending packet from one network to other network. That is routing part is done in the network layer. And you see that in network layer ensures that a packet gets its point of origin to its final destination. So if the two networks are different, if you have a LAN here in one city and in other city you have different classes of LAN, say A or B or C, class A, class B, class C, these different networks, different class of network, you should have a layer 3 device or the network layer device, that is router, which will do the routing. What are the functions of network layer? First is inter-networking, means two networks are connected by some ISPs. So routing, that is the first thing for network layer. Logical address is the second thing, means the IP address. You have to assign an IP address to every PC or router port. So that is logical addressing. That is a very important thing for network layer. IPv4 or IPv6, those addresses are attached to the devices. And routing, that I've already told you, that is from sending packet from source to destination, that is also done by network layer. Now let's come to the transport layer part. So we are seeing this diagram that from session layer, the data is encrypted and the encrypted PDU or the data is entering the transport layer, as well as from the network layer is also entering the transport layer. Transport layer is responsible for process-to-process delivery of the entire message and reliable delivery. Because in case of transport layer, you will see that there is a system of acknowledgement. So if I am sending a data, any file, any email, anything, so if it reaches the destination, then an acknowledgement is sent back to the source so that it's ensured that the data has reached the destination properly. Also, the transport layer is responsible for assembling the data in the destination again. So, for example, the data link layer has cut the data into several pieces or frames, and it has transferred the data to the transport layer. Now, the transport layer sends the data to the destination, and when the data reaches the destination, it also assembles the data orderly. Transport layer provides connection-oriented and also connectionless transmission, but most of the times it is connection-oriented transmission, which is done by some protocols like TCP, Transmission Control Protocol. So this is a connection-oriented or reliable communication, you can say, and acknowledged protocol means acknowledgement comes to the sender. Functions means segmentation of packet messages into packet and reassemble of the packets that I've already told you. Also port addressing, the different port numbers that we see for particular services, and they reside in the transport layer. Flow control, that is also a part of the transport layer, that is maintaining the flow of data between the source and the destination PC. Also it checks the incoming data for some error, just like the data link layer. Now let's come to the session layer. So on top of the session layer, we have presentation layer, and below we have transport layer. Now, session layer is the fifth layer of OSI model, and it is a logical layer which is responsible for maintaining, beginning and ending the communication between two devices called session. This is actually a session means a communication between the devices, and the logical session means the PC is logging in to a particular user is logging, or the user is logged out, and the time difference is known as a session. Also, you are sharing the desktop. There is also a protocol behind that, RDP, remote desktop protocol. That is also a feature of the session layer. So the functions are establishing, maintaining, and ending a session or the communication. And here we see the synchronization of packets and the acknowledgement, the three-way handshake that happens, that is in the session layer. The synchronization packet is sent from source to destination, and also the acknowledgement is sent from the destination to the source. Dialog control, dialog communication, everything happens in this session layer. Let's come to the presentation layer now. The presentation layer, the job is encryption, compression, and conversion or the translation of data. The presentation layer is a sixth layer of the OSI model and is concerned with the syntax and semantics of the information. And it was designed for data encryption, decryption, and compression part. So encryption means to hide the data so that nobody can capture the data or read the data easily. And also compression means to make it less in size. And also translation means to translate any file type, say doc to PDF, that is the translation. So any file type translation, that is also done in this case of presentation layer. Data presentation or translation, that I've already told you. Different encoding systems are there. Data encryption and also data compression. So these are the three salient features of presentation layer. And now it is the application layer. Application layer, every service or protocol, most of the protocols work in the application layer. Is the topmost layer, that is the seventh layer of OSI model, and it enables the user to access the network, and it provides user interface and every services or protocols. Most of the protocols you find here in case of email, file transfer. So in case of email, you see the SMTP or POP3 protocol, and for file transfer, you have the FTP or TFTP protocol, or the access to the World Wide Web, internet, you have the HTTP or HTTPS protocol. Most of the protocols work in the application layer. So every application runs in this layer. So this is an application layer function. Mail services, files transfer and access, remote login. Yes, you have the telnet protocol or SH protocol there in this case of application layer. Accessing the World Wide Web, all these things are done in the application layer. So this is about the theory part for the OSI model. And before moving to the IP addressing part, I'd like to show you some small things in the Cisco packet tracer, how to configure the protocols, some protocols like HTTP protocols in this OSI model. So here you just say take a switch and also take a server. You need a server because services are available in the server only. And you take, say, a PC, connect it to the fast Ethernet, any port you like. You go to the server, you go to services, and you can see that here the HTTP service is already on HTTP or HTTPS, means the web server is running and the website is running on this server. You go to desktop, IP configuration, you configure the IP address, say 10.0.0.100, and on this laptop, say 10.0.0.10, and you open the laptop, you go to the web browser, and you just give the IP address of the web server. You see the Cisco packet tracer that is coming. You can give HTTP or you can give HTTPS. All those protocols are already on in the Cisco packet tracer. So this is a World Wide Web access that you can configure. Also, you can configure many things. Say, for example, you can go to services on the server, and I'm showing you one more thing. That is FTP access. That is the file transfer protocol. You can transfer any file from any PC to the server using this FTP service. Make sure this FTP service is on, and it is using the default username as Cisco and password as Cisco. You can change it anyway, but I'm not doing it right now. Just go to laptop, go to the command prompt, give FTP, and give the IP address of the destination server. You ask for the username, give Cisco, and password as also Cisco. And yes, you are logged in as FTP. So here you can download and upload the file from the PC, the server, and from the server to the PC, you can download the file also. So these are the small things that we can definitely configure using Cisco packet tracer. So these are the protocols that work in the OSI model that I have shown you. Now, so I've discussed with you the OSI model and the protocols, and I've shown you some protocols also. Now, there is one more thing that I would like to show you before I move to the IP addressing. That is a very important protocol known as ARP protocol, Address Resolution Protocol, that is used to know the destination MAC address of the PC. So here, if I take a switch and take for laptops and you connect, and you give IP address to the PCs. Okay, 10.0.0.1. To 10.0.0.3 and 0.4. Now there is a protocol known as ARP protocol, or address resolution protocol, that is used to know the destination MAC address of the PC. So go to the simulation mode, you click on edit filters, and there is the ARP protocol that we want to capture. You just uncheck other protocols because we do not want that. Only ARP is there. Now I'm in simulation mode, and you go to this simple add simple PDU. Say from this laptop, you click on this laptop, see an ARP message is generated, and you just play this. You see an ARP broadcast trigger is reaching the switch, and now it will reach the every other PC. It is not intended for this PCs. It will be negation, and from this PC, a reply will come. ARP reply will come, and it can be captured on this laptop. Now, if you click on this ARP message, you can see that it's an ARP broadcast message. There is a broadcast that is FFFF, means is a broadcast message. You can verify it in outbound PDU. Details also that the target MAC address is unknown. So the destination MAC address is asking. So it is FF, means everything is 255. So it is a broadcast message. So this is the ERP. And you go to the PC. You go to command mode, command prompt, and you give this command ARP space -A. So still you don't have any ARP entries. Anyway, go to real time. Again, you go to simulation and just go to any other PC. Okay, so this. Click on play. All the ARP messages are generated. Yes, you can now see the MAC address, destination MAC address of the PC that it has captured using this ARP table, ARP cache. So this is what I've shown you. I've discussed the OSI model theoretically, and also I've shown you some protocols in the Cisco packet research related to the OSI model. So this was the first part, and our second part of discussion for today is IP addressing basics. So let's start with IP addressing basics now. So what is IP address? IP address is related to network layer, means layer 3, and internet protocol address. IP address is used to uniquely identify a PC in a network. So if it is a very big network, you have hundreds of PCs. And so to identify a PC, how can you identify? By color? No. You can have an IP address for each PC. It is a unique identification for a PC in a network. It is a numeric address, and two PCs cannot have the same IP address, because in that case, it will result in IP conflict. So you cannot give the same IP to two PCs. So they will be out of the network actually. Versions of IP address. IP address has two versions, that is IP version 4 and IP version 6. IPv4 is a 32-bit binary address, and IPv6 is a 120-bit hexadecimal address. But for our Network Plus perspective, we will be concerned with IPv4 only, because later, if we do CCNA, then we'll learn the IPv6. What is the structure of the IPv4 address? See, IPv4 is a binary address. This is 0 and 1, right? Address space is divided in 4 octets, 8 bits per octet, and total is 32 bits. So this is the structure of the IP4 address. So you can see that there are 8 bits, 8, 8, 8, 8, first octet, second octet, third octet, and fourth octet, and every octet is divided by dot. So that is the delimiter or the separator. So this is the structure of the IPv4. Now, what are the IPv4 address types we have? We have two types of IPv4 addresses. One is private IP, that is used in LAN. So if you are going to configure the private IP address in LAN, you want to give IP address to the PCs, your laptop or desktop or servers, you need to give the private IP. And public IP is used in WAN by ISP. So there are two IP addresses, and you can only give private IP address, because if anybody gives public IP also, then the IP address space would have been wasted, where it would have been exhausted long before. Okay, so these are the two IPv4 address types. Next is the classes of IPv4 address. There are actually A, B, C, D, and E. We are only concerned with Class A, Class B, and Class C, because Class D and Class E are reserved for some special purpose that we'll see later. Class A, what is the range? That is 0 to 127. Class B range is 128 to 191. Class C is 192 to 223. Class D is 224 to 239. And Class C is 240 to 255. Now, although Class A range is from 0 to 127, definitely a PC will not have the IP address of 0. Actually, the IP address will start from 1. But this is the range. Now, some points to be remembered: 127 IP, 127.0.0.1, that is reserved for testing NIC, network interface card or LAN card. This is known as loopback address or the loopback IP. So I can actually go to the command prompt of the PC and I can write ping space 127.0.0.1. And if the response is coming, then your NIC is operating normally. If it is not coming, then your NIC is faulty. So we cannot give this IP address to any particular PC. Now, Class D address also we cannot give, because it is reserved for multicast. Now, multicast is a special type of communication. It is communication from one to many or one PC. When it's communicating with a group of PC, then that is a multicast. So you have to configure multicast, and that is IGMP protocol, Internet Gateway Managed Protocol. That is definitely not there in case of our N+, that is in CCNP. So for that, Class D address space is reserved. So we do not use that. Also, Class C address is reserved for higher scientific research or experiment. So also we do not go for Class C address. So only we use Class A, B, and C. Now, network ID and host ID, that is the next part. So what is the network ID and the host ID of the IP address? Network ID means how many networks you get using a class of IP address, and host means PC. In each network or in subnet, how many PCs you accommodate, how many IP addresses you accommodate. In case of Class A, we see that the first octet is network and the last 3 octets belong to the host. So in case of Class A, you get many number of hosts and least amount of network. In Class B, we see it's almost equal, 2 network parts and 2 host parts. And in Class C, you get the maximum number of networks, that's 3 network parts, and the last one is the host part. So in case of Class C, you get the minimum number of hosts. But in case of LAN, we generally go for Class C networks, because Class C has a minimum number of hosts, and in case of LAN, you cannot have many more PCs, because it will create a lot of broadcast. And Class A and Class B has more number of hosts, so actually it is used by ISP in case of public IP. And now we have to understand the subnet mask. So subnet mask denotes an classes of an IP address. So it is a 32-bit value, and it denotes the class of an IP address, and also it differentiates between the network ID and a host ID part of an IP. So in case of Class A, Class B, and Class C, what are the default subnet mask values? We know that in case of Class A, that is network part is the first octet, and we assume that all the bits, 8 bits, are on in the network part. So we get the subnet mask of 255.0.0.0. 0 means the host part, and 255 is the network part. So we get the default mask of 255.0.0.0. In case of Class B, 255.255, because Class B has the 2 network parts and 2 host parts, 255.255.0.0. And Class C, 3 255s for 3 network IDs, and 0 is the host part. So this is a default subnet mask that we give to any PC. So if you provide any IP address to any PC, so in that case, you just press a tab, you see that there is a subnet mask option, and you can go for the default subnet mask according to your class of IP. So this is the basic part of the IP address. what is IP addressing, IPv4 that I've shared with you. And this is a basic part of the IP address. So I think it's clear to you what is a basic introduction of IP address. So today we have discussed actually the two main topics for CompTIA Network Plus. That is very useful certification, and I encourage everybody to go for CompTIA Network Plus to enhance their career in networking. It is very, very useful. It covers a wide range of topics from basic network to advanced network to security level, say encryption, routing, backups, RAID configuration. Everything is covered in this Network Plus certification. So in case of technology level, also in OS level, everything is covered there. So it's an extensive course. So everybody should go for this certification. And we have discussed the two main topics for the Network Plus today. One was the OSI model, that is a basic for every networking, and also with the IP addressing basic part. So I hope you have enjoyed this, and I hope it was informative for this. And also, if it's informative, then please like our channel in the YouTube and Facebook, and also subscribe our channel for this more videos and webinar in upcoming sessions. So I thank everybody for joining this webinar today on CompTIA Network Plus. Thanks everybody, and I'll come with some new topics next time. So that is it for today. Over to you, Patrick.
Thank you, Devashish sir. That was highly useful and highly knowledgeable for viewers for this today's course. And I really encourage everybody to do the CompTIA Network Plus course. It is highly useful as it improves the networking professional's career. Uh, Students who are interested in learning cybersecurity and who are from non-IT background can start the journey by learning CCNA networking from Indian Cybersecurity Solutions. Our trainer, Mr. Debashish, will train you and give you in-depth details on how CCNA networking is done. Together with that, after CCNA, you can learn CompTIA Network Plus. To know more about our course details on CompTIA Network Plus, you can visit our site. It will be given in the chat in the comment section below. On top of that, if you want to know about CCNA modules, do visit our site, and you can keep in touch with us by calling at a toll-free number at 1-800-123-5014, or you can even send us an email at info@indiancybersecurity.solutions.com. I hope everyone have enjoyed the session and have learned something new about it. I thank Mr. Devashish for spending some time and giving knowledgeable important knowledge on CompTIA Network Plus, and we hope to see him again on the new session and some new topics. Till then, please follow us on Facebook at indiancybersecurity.solutions.com, or you can subscribe to our YouTube channel to get more informative videos and tutorials on CompTIA Network. Thank you, everybody. Thank you, sir.